So here we go. Today we're talking about Chapter 8. We're going to be looking over Chapter 8, Section 1, exponential growth. Tomorrow we're going to look at exponential growth functions and word problems. Today what we're doing is we're looking at what an exponential growth looks like in a graph. What does it mean to graph it? So the first thing I want to do is I want to take a generic exponential growth function, f of x equals 2 to the x, and I want to plot the points. So what is, well, f of x equals 2 to the x. When I say x is negative 3, that's just telling me to take 2 to the negative third power. What is 2 to the negative third power? It's not 0. It's not 1. What's 2 to the third power? 8. What does the negative tell us to do with it? Put it over under 1. So 2 to the negative third power is 1/8. What's 2 to the negative second power? 1/4. What's 2 to the negative first power? 1/2. What's 2 to the 0 power? That's always just 1. What's 2 to the first? 2 to the second? 2 to the third? 8. All right. So this is what an exponential growth function would look like if I did a table for it. We're going to look at what this looks at on a graph. So if you have graph paper, you can do this on graph paper. If you want to do this and just sketch it, that's okay. This is your notes, however you want to do this. The next thing is I have that word asymptote up there on the board. I am not going to tell you the definition till asymptote till the very end, but I'm going to talk about the asymptote as we go through. I want you to kind of see if you can figure out what an asymptote is. So here we go. So y equals a times b to the x minus h plus k. This is the generic function when I'm talking about exponential equations. As the late students come in and sit down, we begin. Y equals a times b to the x minus h plus k. This is my generic form when I talk about an exponential function. Just like what we used to have in y equals a times x minus h squared plus k, when I talked about a quadratic, h and k and a do special things. It doesn't change if I go to a different equation. So my question to you is, what does a do? If I have a quadratic equation, what did the a do? It's not slope in a quadratic, it's slope in a linear. What does the a do in a quadratic equation? Do you remember? It does a reflection. It's either, if it's negative, it reflects it down. That's correct. What else can it do? Silence. Remember, a was also a vertical stretch or a vertical compression. It makes it stand up taller or sit down wider. What were the h and the k? That's the coordinates for my vertex. The h moves it left and right. The k moves it up and down. We're going to have the same ideas when we talk about exponential, but let's first start talking about my base b. Unlike a quadratic, I have another type of term, a base. I don't have a base in a quadratic equation, but I have a base in an exponential. I have a base of 2 to the x and a base of 3 to the x. For both of these two graphs, I'm going to start with my x's to be 0, 1, and 2. And I'm going to graph these. And yes, we're going to start by graphing points. But the idea is to be able to graph without a calculator and at the same time, without plotting a bunch of points, kind of know what the graph is doing. So 2 to the 0 power is what? 1. 2 to the first power, 2. 2 to the second power is 4. So my graph starts off really close to the x-axis. It gradually starts to grow. It goes through 0, 1, 1, 2, 1, 4, even 3, 8, and it continues up. The points that I graphed were 0, 1, 1, 2, 2, 4. That is the exponential function y equals 2 to the x power. What happens when I change my base? Well, let's see. Let's plug in x's and get y's. If I let x be 0, 1, and 2, what changes? What's 3 to the 0? 1. Anything to the 0 power is 1. What's 3 to the first? 3. And 3 to the second? Thank you for not saying 6. It's 9. Okay? So if I plot these, my points are 0, 1, 1, 3, 2, 9. Again, it's going to start really close to the x-axis. It's going to start to climb and hit these 3 points and keep going. Now, when I draw these, I have a tendency to draw the arrow on the right, and I don't always draw the arrow on the left. This is going in both directions, positive and negative, as it grows. So I do want arrows on both sides. But my question about this is, what is the difference if I change my base? The 3 makes it steeper, grows faster, because 3 is greater than 2. Totally agree with that. Do you see anything else that changes? Okay. What do they all have in common? They're all going to do that same exponential growth, that same arch. It doesn't give me a U shape. It gives me kind of an arch climb. What else do they have in common? One more time. Where they cross the x-axis, the points 0, 1, and 2 I choose. Could I choose any x's if I really wanted to? I could. These were just the easiest ones to choose. There's one other thing I need you to notice that's the same. Yes, sir? Before the y-axis, they're all really tiny, and then they're going to grow and get larger from there. I agree with that. That shape is the same. They always have the coordinate 0, 1. If I had y equals 5 to the x, will that have the coordinate 0, 1? How about 50 to the x? Anything to the 0 power will give me the point 1. So every single one of these will go through the coordinate 0, 1. That's something that's interesting. That's something that's different. For both of these graphs, the asymptote is the equation y equals 0, which is my x-axis. The asymptote is the equation y equals 0, which is the x-axis. The question is, why is that, and when does that change? And we'll see that as we move along. All right, so here we go. Now that I'm going to focus on a different letter. Instead of focusing on B, let's focus on A, the A in front. Here I have a positive 2 to the x and a negative 2 to the x. Remember the way that exponents work. The exponent works on the number or variable just to the left, which means It's just the 2, the positive 2 that's being taken to the exponent. If I wanted this negative to be taken as part of the exponent, I would literally have to put parentheses around it. So if I draw it blankly like that, the assumption is that negative is outside of the exponent. And you need to know that. Your calculator works that way, mathematics works that way. You need to know, without parentheses, that negative is outside the exponent. So just like we did, I can start with 0, 1, and 2. And just like on the last graph, this is 1, 2, and 4. So I can immediately plot those points 0, 1, 1, 2, and 2, 4. My graph does the same thing. It starts really, really close to the x, and it grows gradually, and it hits three points, and then it grows. Oops. Let's try that again. That's still wrong. And then it grows a lot faster, a lot quicker after it crosses 0, the y-intercept. What happens, however, when I put that negative in front? So 0, 1, and 2 don't change. What happens to my y's? They become negative. So instead of 1, 2, and 4, I get negative 1, negative 2, and negative 4. Zero, negative 1, 1, negative 2, 2, negative 4. Now my graph, instead of being right on top of the x-axis, it's right below the x-axis. And it goes off like that. So whenever a is negative, what happens to my graph? It's reflected below the x-axis. It's reflected below the x-axis. Excluding the fact that I did a little squiggle in the middle of it, that's the way it should look, and that's what it does. Just as the one in black hugs the very top of the x-axis, the one in blue hugs the very bottom of the x-axis. All right, so here we go. So Miss Caitlin back there wants to be included in the video. So we're going to go ahead and we're going to move on to the next page. I apologize for anything they say. So, next page. What else can the A do? We had that the A can flip positive or negative. It can reflect it below the x-axis. What else can happen to the A? Again, my graph here starts the same way. I start with y equals 2 to the x. That graph doesn't change. 0, 1, 2 gives me 1, 2, and 4 as my y's. That is the same graph. Now there's a 3 in front of it. I'm going to color code this one in red. Rojo. Sí, está bien. This class likes to make fun of my Hispanic accent. So, no, I am not going to say Qdoba. Thank you very much. All right. So, do understand in this problem there is no H and there is no K. There is just an A. And this is we're going to get some information off of this. So first of all, let's look at this one here, y equals 3 times 2 to the x power. What's it going to do to my table in blue? It's going to take this table, and none of my x's change. My x's are always 0, 1, and 2. But after I plug that in, remember 2 to the 0 power is 1, but I have to multiply that by 3. So instead of 0, 1, I get 0, 3. 2 to the 1 power is 2. 2 times 3 is 6. So I had to think about that one. Not sure why. And then the last one is 2 to the second power is 4. 4 times 3 is 12. So my graph now moves differently. So instead of just doing 1, 2, 4, it's going to hug the x-axis again, but it's now going to move up a little faster and goes through 0, 3, and then 1, 6, and then 2 and 12. Yes, ma'am. Miss Jessa wants to talk to everybody and say, can I use your eraser, please? All right, so here we go. What happens now if instead of having that 3 in front, I now have a 1/3, a fraction, a number between 0 and 1? Let's see what that does. So when I go and I do my XY table again, the 0, the 1, the 2 are the same. When I do 2 to the x, I get the same numbers, 1, 2, and 4. But when I get 1, 2 to the 0 is 1. 1/3 of 1 is 1/3. When I do 2 to the first, I get 2. 1/3 of 2 is 2/3. Forgive the drawing of the 2. 2 to the x is 4. 4 over 3 is 4/3. And so now I have a different graph. And this graph is going to grow. 0 is 1/3. 1 is 2/3. 2 is 4/3. This one's going to grow slower. It's still going to grow. The red one we call a vertical stretch. It stands up a little taller. The green one is called a vertical compression. It sits down a little lower. A vertical stretch, my A is going to be greater than 1. A vertical compression, my A is going to be between 0 and 1. But when there is no H and there is no K, it does one other thing. Can you see what else it does? They don't go through 0, 1 anymore, do they? These no longer go through 0, 1. They now go through the coordinate 0, A. My y-intercept is different now. Instead of it being 0, 1, it's now 0A, whatever that A is. Questions on that? What are you saying, Drew? Lovely. All right, so here we go. So that's our A. Let's now look at what H will do. Okay. Now I'm looking at my H. Earlier when I worked on my H, and this is where I messed up in my second period. Stop drawing on her, Drew.
I had to even it out.
Okay, that's more than I need to know. All right, here we go. Back to the board. Shh. Okay, here we go. Better girls and boys is all I have to say. Okay. Okay, 0, 1, and 2 are my X's. Drew, don't follow and fondle anybody. My Y's, shh, again, are 1, 2, and 4. I'm going to change my X's now. And this is where my mistake happened in my last class. When I take the power, this is something similar that we did back in quadratics. I put a little arc over here, and I say I want to do the power of 0, 1, and 2 when I do my x's. The problem is that the power is not 0, 1, and 2. It's x minus 3. So I want to decide what x is to choose. X minus 3 equals 0, so x is equal to 3. That's my x. X minus 3 is equal to 1. Add 3 to both sides. X equals 2. That's my x. X minus 3 is equal to 2. Add 3. What did I mess up? Add 3 to both sides. That should be 4. Thank you. I cannot add. So that's a 4. Add 3 to both sides. X is equal to 5. When I plug this into my power, 3 minus 3 is 0. 2 to the 0 again is 1. 4 minus 3 is 1. 2 to the 1 is 2. 5 minus 3 is 2. 2 to the second is 4. So when I have an x minus 3, when my h is 3, it takes each of these points and it moves it to 3, 1, 4, 2, and 5, 4. So my graph, my red graph, looks like this. The blue graph, my original drawing, looks like this. We can say this has a shift or a translation to the right 3 units. It takes each of my x's and moves it to the right 3 units. My green graph, x and y, again, I can look at the 0, the 1, and the 2. And so this needs to be -4, -3, and -2 are my x's, and that should give me my y's of 1, 2, and 4. When I plot this, -4, 1, -3, 2, -2, 4, this is what my graph looks like. Remember, inside the parentheses, I need to do the opposite. So an x plus 4 tells me to go left 4. An x minus 3 tells me to go right 3. Questions on this? Do you remember seeing this a couple times before? Just with different equations, the h and the k and the a really don't do much different, but there's a few discrepancies. As with almost every graph we've done so far, the asymptote is y equals 0. What about your asymptote? Drew, keep your asymptote to yourself. Thank you very much. Y equals 0. The x-axis is my asymptote. It's the x-axis. These graphs all have an asymptote of y equals 0, the x-axis. What does that mean? What does it look like? What do you see? We're getting to that soon. I've dealt with the a, I've dealt with the h. Let's look at my k. Excellent. A gave me a vertical stretch or a vertical compression, or it gave me a reflection. H translated left or right. What's K going to do? Translate up or down. Caitlin, say no. Okay, the point is 0, 1. 1, 2, and 2, 4. My original graph doesn't change. In red. All that I do with this one that's different is my x's don't change this time, my y's do. So when I do 2 to the 0, I get 1 plus 5 is 6. When I do 2 to the 1, I get 2 plus 5 is 7. When I do 2 to the second, I get 4 plus 5 is 9. And what this does is it takes my graph and I get 0, 6, 1, 7, and 2, 9. And that's what my graph looks like. Recognize that my asymptote is now y equals 5. Now with the green one, 0, 1, and 2 again don't change. 0 to the 1 is 0. Minus 6 is negative 5. 0 to the 1 is 2. 2 minus 6 is negative 4. 2 to the second is 4. 4 minus 6 is negative 2. So 0 is now negative 5. 1 is negative 4. 2 is negative 2. And again, recognize that my asymptote is at y is equal to negative 6. So the k shifts my graph up and down, but it shifts more than just the graph. It shifts the asymptote. Yes, sir. It is kind of just one below, isn't it? Let's go back to the very first page that we did notes on. Yes, I can wait. I will pause for station identification. Welcome. This is Algebra 2. I'm supposed to now say the word howdy. Notice, I haven't been using the word notice very often. I have been? Oh my gosh, don't count my number of notices. Okay, here we go. Going back to the very first page that I did. What happens if I make my x negative 4? What's my fraction? It'd be 1 over 16. So negative 4 would be 1 over 16. Negative 5 would be what? 1 over 32. Negative 6 would be 1 over 64. Negative 7 would be 1 over 128. Negative 8 would be 1 over 256. Negative 9 would be 1 over 512. Negative 10 would be 1 over 1024. The asymptote is the line which the graph will approach but never reach. Drew, his hands are nowhere near you. However, your hands are close to him. So, the asymptote. The asymptote. Hey guys, focus. Not on that page. Is a line, not a lane, which a function approaches but is never equal to.